Hi class. So we're going to continue our discussion of exponents, and now we're going to move on to talk about what happens when the exponent of a number is 0 or if the exponent is negative. So far, you've probably only learned about positive exponents and the fact that a positive exponent, for example, represents a repeated multiplication like this. And the number 2 by itself can be thought of as 2 to the exponent of 1. So just one copy of 2, not multiplied to anything. Okay, so far, exponents have represented how many copies of a base are multiplied together. But what happens, well, today we're going to talk about what happens if you see something like this, or you see something like this, okay, or even something like this. Yeah, that's the topic for today, 0 and negative exponents. So to try to introduce that, I'm going to write down some numbers. So first number I'll say is 2 to the exponent of 4, which if you expand it out and multiply it all together, you will end up with the number 16. Okay, let's go down one exponent. 2 to the exponent of 3. And that would be 3 copies of 2 multiplied together. And if you multiply that out, you end up with the number 8. So the question I want to ask is, what's a way of thinking how to get from 2 to the exponent of 4 to 2 to the exponent of 3? And by that I mean, what operation do you have to do to get from one number to the other? What can I add, subtract, multiply, or divide by to get from 2 to the exponent 4 down to 2 to the exponent 3? Equivalently, you can ask yourself, what do I have to add, subtract, multiply, or divide by to get from 16 to 8? Because those are the same numbers. And the answer I'm hoping you'll eventually come up with is we can get from 16 to 8 by dividing by 2. Okay, so we can put 16 over 2, and that equals to 8. Okay, let us go one power down. So the next power down would be 2 to the exponent of 2. If you expand that out, it's 2 times 2, and that equals to 4. So I ask the same question. Can you think of an operation you can do to get from 2 to the exponent of 3 down to 2 to the exponent 2? Add, subtract, multiply, or divide by a number. And remember, that is the same thing as asking yourself, is there a way to get from the number 8 down to the number 4? And you may, after a minute, come up with the idea of doing what we did above, which is divide by 2. If you divide 8 by 4, you can get to 2. So perhaps we see a pattern emerging. If we want to go down one exponent, perhaps the way to do it is to divide by the base. So 2 to the exponent of 1 is just equal to 2. Okay, nothing special there. But how can I get from 2 to the exponent 2 down to 2 to the exponent 1? Well, the answer is actually divide by 2. Okay, so we have a pattern. 16 divided by 2 is 8. Divide by 2 is 4. Divide by 2 is 2. So what would happen if we go down one more step? What if we try to keep going and divide by 2 again? So we're going to work our way backwards. So 2 divided by 2 equals to 1. Right? 2 divided by 2 equals to 1. So if I keep following this pattern of dividing by 2, I'm going to get down to 1. Now, on the left side now, what happens if I follow the pattern on the left side? Well, what is the pattern on the left side? Well, the pattern on the left side, I have 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1. So the next logical step in the pattern would actually be the number 2 to the 0. The exponent is going down by 1. So what I'm trying to say is that perhaps 2 to the exponent of 0 should simply equal to 1. Okay, maybe 2 to the exponent of 0. And you don't know what that means because like before, exponents were repeated multiplication. But 2 to the 0, it's like how many copies of 2? Well, 0 copies of 2. But the answer is not actually 0. 2 to the exponent of 0, the answer is not actually 0. It turns out if we follow this pattern of dividing by 2 every time we go down a power, the answer is equal to 1. Okay, so 2 to the exponent of 0 equals to 1. But what happens if we insist on keeping on going down the pattern? So what if I go down one more power? So what on earth would I write for 2 to the exponent of negative 1? Simply going down by 1. And going down the integers by 1, you reach negative 1. And what on earth should that equal to? We cannot think of this as repeated multiplication anymore. We're into kind of different territory here. And to answer that question, what we are going to do is simply follow the pattern of dividing by 2. So if I follow the pattern from the step above it and divide by 2, I have 1 divided by 2, which you may think 0.5, but I'm going to be writing it as a fraction, 1 over 2. So this is new. This is your first experience with a negative exponent, and what I'm telling you is that 2 to the exponent of negative 1, the value should be 1 over 2, half, if we're following this pattern of dividing by 2 every step we go. Okay, let's go down yet another step. We're going to go down another exponent. So negative 1 drops down to negative 2. What on earth should 2 to the exponent of negative 2 equal to? Well, we're going to answer that by following the pattern of dividing by 2 again. So we have 1/2 divided by 2. Our answer should be 1/2 divided by 2. And I'm just off to the side. I'm going to do a little rough work here. 1/2 divided by 2. So to divide fractions, we're going to keep, change, flip. Okay, so we kept the half, we changed division to multiplication, and we flipped 2 to 1 over 2. So now we get 1/2 times 1/2, which is actually 1/2 squared. Okay, so the answer is 1/2 squared. So what I'm trying to say is that 2 to the exponent of negative 2 should actually equal to 1/2 squared. Half times a half. So that, in general, is what's going to happen with negative exponents. I'm going to write down a rule on the next page. I will just call them rules for 0 and negative exponents. And these are the rules you're going to have to follow. You can consider them exponent laws if you want. Okay, first rule is going to be for an exponent of 0. So I'm going to write any value. I will actually. Any value to the exponent 0 equals 1. We saw that with 2 to the exponent of 0 on the previous slide. We followed the pattern and we got 2 to the exponent of 0 equals to 1. If we do a similar pattern for any other base other than 2, we would actually come up with the same conclusion, that any base, it could be 2, it could be 3, it could be 4, it could be even a negative number. If we raise it to the exponent of 0, the answer should be 1. Okay, so that is the first rule for today. That is how I want you to handle when the exponent is 0. There is only one exception to this. I'll write that off to the side. There's one exception to this rule. If you have the number 0 to the exponent of 0, that is a little different. 0 to the exponent of 0 is something that we call undefined. It has no value that it should be, or at least there's like an argument as to what value it should be. If you think about it, let's do a regular positive exponent. 0 to the exponent of 2, for example. 0 squared. Well, that means 0 times 0, and 0 times 0 is 0. Okay, what about 0 to the exponent of 1? Well, 0 to the exponent of 1 is simply one copy of 0. And the answer is 0. So it seems like if 0 is the base, you multiply a bunch of zeros together, the answer is 0. You think you multiply a bunch of zeros together, the answer is 0. However, what if you have 0 copies of 0? When you have 0 copies of 0, then what is it? Well, if you follow this pattern of 0 to the power of anything should be 0, that would be what half the people in the world might think intuitively. But if you follow the rule here and think that anything to the exponent of 0 should equal to 1, well, now we have a debate. Okay, we have two possible answers for 0 to the exponent of 0. So that debate has not really been settled. So we actually just don't even assign it any value. 0 to the exponent of 0, we're just going to call it undefined. We're just not going to worry about it. But anything else to the exponent of 0 equals to 1. You can check on your calculator. Okay, so any positive number to the exponent of 0, you can check that on your calculator if you want. It's going to give you an answer of 1. It can be a decimal to the exponent of 0. You can check on your calculator. 2 to the 0.5 to the exponent of 0. The answer is going to be 1. You can have negative numbers. Make sure they're in brackets. Negative 3, for instance, to the exponent of 0. You can check that on your calculator. The answer will be 1. What if there is no brackets? Just as a review, what if there is no brackets? Well, then the negative sign is not getting hit by the exponent. So the negative sign stays there. It's a chilling negative. And however, the 3 to the exponent 0 part, okay, the 3 to the exponent 0 part equals to 1. And then we're just going to copy the negative sign in front of it. So that answer is -1. Be careful about that one. It can be a fraction. So let's say 2/5. If it's in brackets, again, it's got to be in brackets, to the exponent of 0. That equals to 1. What if it's not in brackets? What if it looks like this? If it's not in brackets and it looks like that, you have to understand that the exponent of 0 is only hitting the numerator. It's only hitting the 2. So the numerator, 2 to the exponent of 0 equals to 1, and the denominator is left unchanged. Okay, so it makes a big difference if there's brackets or not. You're going to have an irrational number like pi to the exponent of 0. You can check that on the calculator even. The answer is 1. And you can even have variables. Let's say x. X to the exponent of 0. The answer is also going to be 1, sort of, as long as x is not equal to 0. It's a special case. So if x can be a variable, if x is allowed to take on any kind of value, No matter what value it takes on, when you put it to the exponent of 0, it will equal to 1, except if x is 0. Then you get 0 to the exponent of 0, which is undefined. Okay, so that is the rule for an exponent of 0. The answer is 1. What if you have to simplify something like this? X squared y to the exponent of 0. Again, you have to ask, what is the exponent of 0 hitting? In this case, it's only hitting the y variable. It's only hitting the y variable. So y to the exponent of 0 equals to 1. The x squared is unaffected at all. So the answer is going to be x squared times 1. But anything times 1 is itself, so you don't actually have to write times 1. So the answer to that is just x squared. What if there are brackets? What if it's like this, x squared y in brackets to the exponent of 0? Then what is the exponent of 0 hitting? It's actually hitting everything. It's hitting everything. The whole thing will equal to 1. Okay, so that's an exponent of 0. Now we're going to go with negative exponents. And again, I'm going to write a rule. If the exponent is negative, you're going to do a two-step process here. I'm going to say flip, in quotation marks, the base, surround it with brackets, and then finally change the exponent to positive. So I'm not going to go deeply into why this should be the rule. We sort of got into it when we did all of those powers of 2. So for example, when we did 2 to the exponent of negative 2, the answer ended up being 1/2 to the exponent of positive 2. So when I say flip, I mean you change 2 to 1/2. And then you surround it with brackets, as I did, and then you change the exponent to positive. So the exponent went from negative 2 to positive 2. So the word flip means, like, that's not a proper math word. It means to take the reciprocal. There's a special word in math called reciprocal. And that's basically when you take a number and you flip it in terms of its fraction. So, for example, 2/3, if you flip it, quotation marks, if you flip it, it becomes 3/2. So that's what flipping means. You flip it as a fraction. Now, if you have just an integer, like the number 2 that we did, I'll just pick a different one. Let's say the number 4. What does it mean to flip the number 4? Well, it means to flip it to 1/4. Because you can think of the number 4 as 4/1. And I would flip to 1/4. So that's what I mean by flip. Okay, do another example. Let's say 3/7 to the exponent of negative 4. We have a negative exponent there. And if you're uncomfortable with negative exponents, what we do is we flip the base. So 7/3, surround it with brackets. and then change the exponent to positive. Okay, so that is the rule of how to handle negative exponents. It's really, you change them to positive exponents. And we're perhaps more comfortable with positive exponents, so that's why we do it. Then we can calculate things with positive exponents. So we'll give you some examples in algebra or polynomials. So the example, the instruction would be simplify. And you may have something like this. A squared b to the exponent of -3. Well, actually, we'll start with that. Now, I'm going to change the instructions too. That's probably not the best wording for instructions, so I'm not going to say simplify. I am going to say rewrite using positive exponents only. Rewrite the expression using positive exponents only. This will be my first example. Okay, so a squared b to the -3. The first thing I want you to realize is that the a squared does not have to change at all. It already has a positive exponent, so it already satisfies the requirements of the question. However, b to the exponent -3, that's what we have to change. So we have that -3 exponent, and if you follow the rule from the last slide, you flip it and put it in brackets. So b flips to 1 over b, and then you change the exponent to positive. So that could be a valid answer. Usually this gets simplified, so usually it simplifies to a squared over b cubed. Okay, so I didn't show all the steps to get that, but basically what happens is the exponent of 3 gets attached to the 1 and also attached to the b. Okay, so it's 1 cubed over b cubed. But 1 cubed is just 1. And now we're just multiplying fractions. So we really have a squared times 1, which is just a squared. And then the denominator, we have 1 times b cubed, which is just b cubed. So that's how I got from the second to the third step. Okay, so that's rewriting it using positive exponents only. We'll try another one. Let's try x to the -2, y times x to the -1, y squared. Okay, we'll try that, rewrite it with positive exponents only. So there's lots of approaches we can take here. The first approach I will take is to apply a previous exponent laws. When multiplying powers of the same base, we can add the exponents. So when I look at this, I look at the x's first. I will look at the x's first. They have the same base. They're being multiplied, so I can add the exponents. -2 plus -1 makes -3. And then I will look at the y's, and I'll do the y's. So it's y times y squared, which is y to the +3. Okay, so that's one step, just applying an earlier exponent law. Now, I'm not done. The question asked me to rewrite using positive exponents only. So the y cubed is okay, it already has a positive exponent. But the x to the -3 is not okay. And what's going to happen, I'm going to not show all the steps again, but if you see a negative exponent, it's basically going to go to the other half of the fraction. So the x to the -3, we're going to send it down to the denominator. and change it to x to the positive 3. Okay, so that is, we have to rewrite the negative exponents into positive. So for this one, the y cubed and the z6 are already having positive exponents, so we will leave those alone. But the x to the negative 9, we're going to take that and send it downstairs, changing the exponent to positive. Okay. Now every variable has a positive exponent. One more I just thought of. What if you have something like this? 1 over c to the negative 3. 1 over c to the negative 3. Okay, so interesting. So the first thing, I'll keep the 1 as it is. I'm going to deal with the c to the negative 3. So I would flip the c, making it 1 over c, put it in brackets, and put it to the positive 3. That would equal to 1 over 1 over c cubed. Okay, that's just applying 1 cubed is 1 and c cubed is c cubed. And that looks really strange. That's actually a division of fractions, if you look closely. So it's really 1 divided by 1 over c cubed. And how do we divide fractions? Well, you can say keep the 1, change the divide sign to multiply, and flip the second fraction. So 1 over c cubed turns into c cubed over 1. So now it's 1 times c cubed, which is c cubed. So that's the answer. Now that's a really long way to go. I would suggest you try to just kind of visually remember this pattern. Whenever you have a negative exponent in a fraction, just send it to the other half of the fraction and change the exponent to positive. Okay, so I'm going to actually write that down. When you have negative exponents in parts of a fraction, just send the factor to the other half in quotation marks. Not sure what quite to call it, so I'll call it half, like upstairs, downstairs, numerator, denominator of the fraction. And change the exponent to positive. Okay, so what I mean by that, well, I'll just do one example. So again, rewrite with positive exponents only. Rewrite with positive exponents only. We'll go with a's, b's, and c's here. I'll say a to the negative 3, b 4 over c to the negative 2, d to the negative 1. Okay, so I've got that expression there. The instructions are to rewrite it with positive exponents only. Now, if we follow the shortcut I just wrote, basically whenever you see a negative exponent, I'm just going to draw the fraction line there first. Whenever you see a negative exponent in a fraction like this, just send that factor to the other half and change the exponent to positive. So the a to the negative 3 is on the top. I'm going to send it downstairs and change the exponent to positive 3. The b to the 4 can stay where it is because it already has a positive exponent. The c to the negative 2 is downstairs. We can send it upstairs if we change the exponent to positive. And the d to the negative 1 is downstairs. We can send it upstairs if we change the exponent to positive 1. But we often don't write the number positive 1 as an exponent because it's just one copy of itself. That would be the answer to this question. All right, so a lot was covered there. Basically, you'll now get questions with exponents of 0 and negative exponents mixed up with all the exponent laws you just did over the past 2 lessons. Okay, so the homework you'll get is a big mixture of questions. One of your first jobs is to, well, you got to keep the exponent laws straight, basically. All the exponent laws plus what to do when the exponent is 0, plus what to do when the exponent is negative. You have to think about all of that at the same time to carefully simplify these kinds of fractions. Okay, so good luck with that.